everyone, Jack here, and I wanted to just do a quick video overview of the latest project that I'm working on. It's called GadgetBox, and traditionally I've worked more on FPGA boards, but this time I'm going with an Arduino Leonardo, and I'm taking the basic Arduino Leonardo design and I'm making it fit into an enclosure and setting it up so that you can connect up to 4 what I'm calling ECOGs for electronic cogs that are really kind of like mini shields. But this design will allow you to connect 4 ECOGs without conflicting pins or stepping on each other, and it's very easy to figure out how to connect them without any conflicts. So let's take a look at the design here. I've got a project set up at hackaday.io, and you could read some more information and also any updates that I do to the project I'll be posting here. And here's a couple pictures. So this is the very first prototype that really was just kind of seeing if everything works. It's kind of ugly, but I just wanted to get basic dimensions down and all that sort of thing. So made some progress since then. And this is what version 1.4 of the board is looking like. And one of the things you can see is down here in the corner there is a connector for a lithium-ion battery pack. And that's one of the goals for this project, is I want to be able to put a battery pack underneath the circuit board here and have this thing run without any connections to USB or power, because this is really meant to be an IoT device. So let's take a look at the design here in Eagle, and you can see I started out with the base Arduino Leonardo design, and I took out the power design and I replaced it with a more efficient design meant for battery operated, and I took the best design I could find was the Adafruit feather design, and so it comes with a battery charger and a nice low power switching power supply. I think it's switching. I should double check that. I went through a couple different. I used the LilyPad design first, and then I discovered the feather. I really like that design better. So let's go back and look at the circuit board here. So maybe we should talk a little bit about how the scheme for connecting ECOGs works. And so if you look here, there's 4 different ECOGs, or 4 different quadrants that you can connect an ECOG. So you've got AL, A high, B low, B high. So each one has 8 general purpose I/O pins, and in the case of BH and AL, those 8 general purpose pins are actually shared. So let's take a look. So if you look at 0, pin 0, pin 0 is actually going to, it's shared on both ECOG connectors. Now the other thing to note here is that each ECOG connector actually has, let's see here, it actually has 2 rows. So this is the GPIO row, and then this here, is what I'm calling the bus row. So, like I said, I've done a lot of work with FPGAs, and one of the things I did for the Papilio FPGA board is I came up with this concept of wings. And with an FPGA, it doesn't really matter how you organize the pins, because each pin is equal. But I made dozens of wings for this FPGA. Over the years, I've made a lot of wings for the FPGA, the Papilio FPGA platform, and a distinct pattern started to emerge. And what I've noticed is pretty much every ECOG that we'd want to make, they're going to use probably 4 at the most GPIO. They're going to, or they might be SPI, or they're going to be I2C, or they're going to be UART. And for UART, we can always use software UARTs, so we can always just rely on using any of the GPIO pins for software UART. So basically, if we provide all 4 of those functions to every single ECOG connector, then it's going to allow us to universally connect almost any kind of ECOG that we can dream up to build. So what I've done is I've separated each ECOG into a row of GPIO pins, so 8 GPIO pins. There's ground at the top and then 3.3 volts at the bottom, and then the second row is going to be all of your pins that contain buses. So let's see if we could just here. So it's going, the first you've got SPI, so we've got SPI Mosey, SPI MISO, SPI Mosey, SPI SEK, and then each individual ECOG is going to have its own chip select. So for AL, so we're in AL right now, so for AL it's got its own dedicated chip select. And then for BH over here, it's going to have its own dedicated chip select pin, and so forth. So every ECOG has its own dedicated chip select pin for SPI, and that allows us to share one SPI connection, or one SPI master controller between 4 different ECOGs. Okay, and then going down, we've got I2C. So each ECOG will have I2C SDA and I2C SCL. Additionally, each ECOG has its own reset line. So we can make an ECOG that can actually reset the Atmega32U4 microcontroller. Okay, so that kind of gives you a general idea. Now, I made a legend here, so I want to make this as easy as possible so that when you connect an ECOG, you're not going to step on any other pins. You're not going to have any conflict. So what I did is I made a legend here. So a circle, right here we've got a circle. Here we have circles. A circle means digital. It's a digital I/O pin. A triangle. So these are the triangles. A triangle means it's either going to be an analog pin. It means it can be an analog pin, and it is also a digital I/O pin. Okay, a square is a PWM pin and a digital I/O pin. So we've got 3 squares, 3 triangles, and we've got 2 just basic GPIO pins on each ECOG. Okay, so now let's look at how we would connect something with this scheme. So I'm going to go into the schematic. I'm going to import one of the existing ECOGs. So let's import a Wi-Fi. So this is an IoT device. This is meant to be an IoT device. So there's going to be all kinds of ECOGs for like a ESP8266 Wi-Fi ECOG, or if you prefer Bluetooth. So you can select what kind of communication device you want. Do you want Bluetooth? Do you want Zigbee? Do you want Wi-Fi? They've all got their strengths and they've all got their weaknesses. So I think it's best that we should be able to pick and choose what we want. In this case, let's do Wi-Fi. Okay, alright, let's go back to our circuit board. Alright, so here's our Wi-Fi ECOG. So you can see that Wi-Fi ECOG is clearly going to be marked with what it's going to use. So in this case, it's going to use 4 GPIO pins. So that means, looking at the diagram, we can use anything, we can connect it to anything that's a circle, triangle, or square. So let's go ahead and move this, and let's move this to the AL slot, and we'll see that when we, oops, here we go. When we connect it, it's going to show that we're using 4 of the, we're using these 4 shared GPIO pins. So when we connect something to BH, we need to make sure that we're not going to be connecting we're not going to be conflicting with these 4 pins. So first of all, we look at the legend and make sure that the type of pins that we have are correct. So 4 circles are going to work with any type of pins. Okay, so let's go ahead and open up another one. All right, let's do a joystick. Let's add a or actually, let's say we want to add a display. Actually, let's add the display later because I want to make a point here. Let's go back to that joystick. So I want to show how you prevent pins from conflicting. Okay, so now an analog device, there's a note here that says it's only going to work on the AH and BH ECOG locations. Okay, so let's take a look at, so here's our joystick that we just added. So now we see that what it's going to use, it's going to use one GPIO pin and it's going to use 2 analog pins. So let's go ahead and grab it. We're going to move it. And you can kind of see that just based off the legend that those triangles are only going to match if you put it in, so it's only going to match up with this if you put it in the AH, or so if you try and put it in AL, the triangle doesn't match up, so it won't work in AL. If we put it in BL, it does match up. If we try and put it in, or I'm sorry, BH, I said BL. It does match up to BH, but it won't match up with BL. Okay? So 2 things we're looking for. We're making sure that we're matching the shapes and remembering that a circle can be anything. And then also making sure that we don't conflict. So if we put this in the BH slot, we're going to match up with the shape, and then we can also see that this pin is used, this pin is used, this pin is used, this pin is used, all by this ECOG. Pin 4 is not used by anything, but pin 5, 6, and 7 are used by the BH ECOG. We have no conflicts here, so both can coexist and use the pins that they need with no problems. Okay, so now let's go look at that TFT display that we used. Now the TFT display, if we go and we look at the circuit board or the schematic, we can see that the TFT display, it uses an I2C bus. So in this scenario, in this case, we aren't actually going to use any of the GPIO pins, and each ECOG actually is connected to the I2C bus, so there can't be any conflict no matter where we connect it. So we can just be free, we're free to put it anywhere, and there's no markings on this ECOG because you can put it in any one of the spaces. Okay, so that pretty much wraps up how the ECOG scheme will work. Once I actually get the prototypes finished, once I get version 1.4 in hand, I'll be able to record a video that maybe makes it more clear. But thanks for watching.